Today's lesson we're going to call Advanced Exponents, and basically what it's going to do is have some missing pieces where we need to find either an exponent or a coefficient as part of the problem. So if you take a look at our first problem, you can see that we're looking at 4x to the fifth times 2x to the m, so we're going to need to find that m, and all of that should work out to nx to the 11th. So first thing we're going to do is divide our screen into two parts here, and we're going to concentrate on the coefficients first. So we've got a coefficient of 4, 2, and then the coefficient that should be our end result, which is n. And then we're going to create an equation for that set of coefficients. So if we think about it, our exponent properties tell us that we multiply coefficients. So we should have 4 times 2, and that should work out to n. So our n value is just simply 8. We can record that over on the right-hand column. Our exponents, however, also have a missing piece. So if we focus on the exponents, we have 5, m, and 11. So our equation for the exponents, if we think about our properties here, everything is being multiplied, and our multiplication rule says when we multiply like bases, we can add the exponents. So 5 plus m should equal the total exponent of 11. And then we can simply solve that one-step equation by subtracting 5 on both sides to get that m equals 6. And then the next two are going to file suit with that same concept. So let's divide our workspace into two, and we'll take a look at the coefficients first. So we have 7, n, and 21. So if we build our equation there, we'll be doing 7 times n, and that needs to equal out to 21. So when we divide that, we'll get n equals 3. And then for our exponents this time, we have an m, a 4, and a 9. So when we build this equation, again, it's all multiplication, so we'll be adding m plus 4, and that needs to equal 9. So when we subtract over the 4, we get m equals 5. And the last one that we can see here, again, we're going to build these equations right now so that when the problems get a little bit more difficult, we have a structure in place. So get in the habit of actually writing down the equations for each of these. So our coefficients, we've got n, 5, and they need to add up or multiply out to 20. So n times 5 equals 20. And notice that in this last problem up here and the problem we're working on there, it doesn't matter that the n is first or second. We're still multiplying, so the order doesn't really matter. Either way, we're going to divide. Our n here should be 4. And then again, focusing on the exponents, this time both exponents are given on this side. We just need to find the sum for the one on the other side. So if we write our equation, it's just going to be 5 plus 3 equals m, which that should equal out to 8. Now if we go ahead and scroll down here to our bottom set of 3, things change up a little bit. Again, we're going to divide it into 2. Actually, before we do that, we're going to do one step. You can notice here that in this particular section, the second quantity is being squared. So that's going to change things slightly. So what I'm going to do first is rewrite this. The first quantity is not going to change, but the second one I'm going to go ahead and write it 2 times. So 4x to the m times another 4x to the m, since that's what it means to square something. And now it's going to become a problem just like the last two. So if we focus on our exponents this time, or our coefficients rather this time, we're going to have a 3, a 4, a 4, and then they need to all multiply out to our end result coefficient of n. So we can do 3 times 4 times 4 equals n. And 3 times 4 is 12. 12 times 4 is 48. Then for our exponents, again, we're going to have 3 of them, 5m, m, and they need to total out to 13. So now we'll do 5 plus m equals 13, or 5 plus 2m equals 13. Subtract over the 5, we're left with 8, and then we'll divide to find out that m equals 4. Okay, so the new strategy here is to apply the squared symbol, or whatever the outside exponent is that we were looking at here. So then it becomes more like a problem from the top. So we're just going to expand and make it a little bit longer, but that'll help us in building the equations that we need to do there. And again, if we take a look at the next one, so the second quantity is squared, so that means we need to write it 2 times. We're multiplying it by itself. So 5x to the m times another 5x to the m. And now again, we'll focus on the coefficients first. This time our coefficient is on the left-hand side. So we have n times 5 equals our total this time of 50. I'm going to switch that around and put the number first when I rewrite here. So in this case, our n needs to be 2. And then looking at our exponents, this time again, we have 2 m's and another number, totaling out in this case to 16. So we'll just add those up, and I'm going to jump straight to 2m this time. And we get our m value of 5. Right? And then the last problem on this particular page, again, they've got a squared quantity as our second one, but this time it has 2 n's. So our first quantity, instead of having 2 m's this time, we're actually going to have the coefficient twice. So nx to the 6th times a second nx to the 6th. And if we focus our attention on the coefficients, we have 2, n, and an 18. So 2 times n, 2 times n equals 18. So that would be 2n squared equals 18. So n squared equals 9 when we divide both sides by 2. And then if we think about how to undo the squared sign, we need to take the square root. So our n value here would be 3. Then if we focus our attention on our exponents, this time we're back to 1m as our exponent and 2 of the others. So we can do m plus, and you could go straight to 12 if you want to, or just m plus 6 like I wrote it. And when we subtract here, our m value will need to be 8. All right, feel free to take another look through at these examples, and good luck.